Okay, we are on page 11 in the chemical bonding packet, and we are going to cover Lewis dot diagrams today. Lewis dot diagrams are a visual representation of the valence electrons in any element. So remember, valence electrons are electrons in the outermost energy level, so the ones farthest away from the nucleus, and they are the ones that take part in bonding. So page 11 in the packet, and make sure you have your periodic table out at the same time. You want to find lithium on the periodic table. It is an alkali metal, which means it has one valence electron. And when you're drawing a Lewis dot diagram, you start off just writing the symbol for the element. And when I do this, I think about it as these things split up into 4 quadrants. And what you want to do is put an electron, a dot, in each quadrant before you start doubling them up. So I tend to start at the top and work my way clockwise. Now lithium is pretty easy. It only has one valence electron, so I'll just put one dot at the top. So that is telling you lithium, when it forms an ionic bond, for example, it donates that one electron. And that is why the alkali metals have a positive 1 oxidation number, because they all behave the same. Nitrogen now is a nonmetal. Towards the right on the periodic table, it has 5 valence electrons. And remember, to get the valence electrons, you just count from left to right on the periodic table, skipping the transition metals. So when we work with nitrogen, remember, put a dot in each quadrant before you start to double them up. So you have 1, and work your way clockwise. 2, 3, 4, 5. And now when you draw it like this, what it's showing you is that these 2 electrons that are paired off at the top, they are considered not available for bonding. But the electrons that are by themselves, and there's 3 of them in this case with nitrogen, they are considered available for bonding. So what happens is nitrogen will tend to form 3 bonds because it has those 3 electrons that are by themselves. And that is why, if you're talking about if it's in an ionic bond, if it's accepting electrons, it accepts 3 to get them all paired off, and that's why nitrogen ends up with a -3 oxidation number. Let me get that out of there. Beryllium is an alkaline earth metal. It has 2 valence electrons. So you write beryllium, and again start at the top and work your way clockwise. So beryllium has those 2 valence electrons that it tends to donate, which is why it ends up with a +2 oxidation number. Fluorine is a halogen. It has 7 valence electrons, so we're going to have 7 dots around it. And again, start at the top, work your way clockwise before you start doubling up. And there's fluorine with 7 valence electrons. So what it is telling you is those 3 pair are not available for bonding. But this 1 electron that's by itself is available for bonding. So fluorine tends to make 1 bond because of that 1 lone electron. Neon is a noble gas. It has 8 valence electrons. So when we work with neon, again, start at the top, work your way around till you get to the right number of valence electrons. You have neon with 4 pair, so none of them are available for bonding. Neon and the other noble gases have as many electrons as their valence shell can hold, so they are considered stable. They tend not to react much. Now the transition metals like gold, they're a little tricky because they are filling in the D sublevel. Remember when we were doing electron configurations, S, P, D, and F. The D sublevel actually tends to not take part in bonding. So, and we're not really going to focus on these too much, but when you have a transition metal, you have to remember that you'll only show the S and P orbitals. So gold, you can kind of think about those transition metals. They'll look a lot like the alkaline earth metals for us. You have gold, you put 2 dots around it, and it's good how it is. Like I said, we're not really going to focus a whole lot on the transition metals doing electron dot diagrams. Now, one of the things you want to pay attention to, an example of what not to do. So for example, for fluorine, we know it has 7 valence electrons. You don't want to just put these things anywhere around here. You may have the right number of dots around it, but if you don't have it drawn correctly, it's not giving you any indication of how many bonds it will make. So something like that isn't helpful. So what we want to focus on is making sure you have them paired off where they're supposed to be, and